Hi, Eddie. So, we're going to take a look at these problems you sent. So here we go. C is the center of both circles. Let's look at this diagram before we look at the choices. We know that AC and CD, let me get a different color, have to be congruent because they're both radiuses of that circle. And also CE and CB have to be congruent because they are radiuses of that bigger circle. And what else do we know? Let's see. DE probably is equal to AB, but I'm not sure that we can say for sure that we know that. Let's see. Yeah, well, let's see what the choices are. Okay. So BCE is isosceles because we know that CB is the same as CE because they're both radiuses of that larger circle. So segment AB and AD, now we don't know that. AC and CD, yeah, we both know they're the same because they're both radiuses of that smaller circle. AC and AD, no, we don't have a reason to think they're the same. CDE is isosceles. No, I don't think we have any reason to know that either. So there you go. Let's look at the next one. Oh, there's three of them here. Line CD is perpendicular to the bisector. So we have segment AB. Then we have, line CD is the perpendicular side bisector. Okay. So there we go. The lines intersect at point E. So we know that these are all right angles. We know that segment AE is congruent to segment EB because it's a bisector. So E is closer to B. No, it's the same distance from B as it is from A. E is the same distance. Oh, so E is not true. Let's see about the next one. E is the same distance from A and B. Yes. DC is the perpendicular bisector. That means it bisects the segment AB. That means E is the same distance from A and B. So that's definitely true. And E is not closer to A. So it's E is the same distance from A and B because DC is the perpendicular bisector. And E is a point on that bisector. So E is the same distance from A and B by definition. So let's see. Number 3. So quadrilateral ABCD. Let's do this. Draw 2 points, A and B. Draw a circle centered at A with radius AB. Yeah, that's more like an egg-shaped circle. Let me try again. So we want to go through here and here and here and here and here and here and here. Oh, no, a little further out. Let's see, centered at A with radius AB. So that's this. There we go. Draw a circle centered at B with the same radius. So that's going to go through here and here and here and here. So it's kind of going to go like that. It's a little bit too flat, that side of the circle. Let's make this more like a circle. Okay. Label the intersection points of the two circles. Circles C and D, then talk about circles C and D, but I guess it's those two circles. Let me use a different color. Okay. Draw segments AC. Oh, C and D are the intersections. Okay. They're not the names of the circles. That's C, that's D. So they want AC, BC, AD, and BD. All right. So certainly there are four congruent sides because, well, let me think. Yeah. Each of those sides is a radius of a triangle, of a circle, and the two circles have the same radius. So they're all equal. They're definitely not congruent angles. You can see that. They are four congruent sides. That's it. They're definitely not four congruent angles. Which statement gives the best definition of a circle? All points that are the same distance from a given point. That's true. All points that are the same distance from a given point. And that's right. Nothing wrong with that. So I can't see number 5. Let's see. Number 9. Create two circles at A and B with length AB. So that's kind of what we did before. That's drawing these two circles. I'm going to draw this part of the circle. Create a line segment. Let's see. Oh, so first we create the two circles, then we create the points of intersection, C and D, and then we join C and D. And that makes our perpendicular bisector. So it's 1, 2, 3. All right. What triangle shows segment AB as the perpendicular bisector of the triangle? There's no such thing as a perpendicular bisector of a triangle. AB is a perpendicular. So, I mean, if one of those is right, it has to be A. A is the only one that's a perpendicular bisector of anything. I don't know what that means, of the triangle, but it's certainly of one side of the triangle. It's the perpendicular bisector of that one side of the triangle, because you can see it makes a right angle with that side and it cuts it in half. So if you got to choose one of those, it's the first one. I would have said none of the above, because perpendicular bisector of the triangle, I don't know what that means. It's the perpendicular bisector of one of the sides of the triangle, which none of these other ones are. So there we go. So there's number 6, but I think we don't see the whole question, so we're not going to do that. It looks like the last one, I think. Oh, no, there's 2 more. Oh, here we go. So we have line J, mark 2 points. Construct congruent circles, and I see them right there. Construct line G, yeah, through the intersection, good. Now we have a circle centered at one intersection point. All right. Congruent circles H and K. Centered at points on G, let's see. Yeah, okay. Good. Construct line I through the intersection points. Okay, good. So this is a careful way of constructing perpendicular and parallel lines. It is constructing line G as the perpendicular to line J, and then we constructed in a similar way line I perpendicular to line G, so that makes line I and line J parallel. I and J parallel, that's the 4th one. I'm going to mark these on here. So I and J in parallel, that's true. G now, G is not parallel to any of these other lines here. J is perpendicular to G, and I is perpendicular to G. Those 3 are true, the rest are not. So let's look at the last one. 3 circles with center A, B, and C. So let's see. Okay, so they all have the same radiuses. And what are we trying to find out? What? 7, oh, I see. So yeah, that's equilateral, right? Definitely. Y segments A, B, and AC. They are both radiuses of the circle A, radii of the circle A. They are both. We're just talking about 2 segments, so not they all, but they both. They both have the same length because they are both radii of circle A. All right, that's it. I'll get this link over to you as soon as I can.